Welcome students to the series of lecture on fixed income. And in this series of lecture of fixed income, we are going to do prediction of bond prices with the help of duration and convexity combined. Till now, we have seen that you can do the derivation or you can do the prediction of the bond prices with the help of duration, right? So if the duration is 5 and interest rate changes by 2%, then the price will change by 10%. We discussed that. But now, because we have studied duration and convexity, until now we have studied only one flavor of duration and convexity, that is effective duration and effective convexity. So with the help of whatever we have discussed in duration and convexity, now our responsibility is to predict the bond price due to the change in interest rate, not only because of duration, but also with convexity. So generally in the examination or in the curriculum, you will get a question like this, where they will talk about, hey, this is the duration of the bond, this is the convexity of the bond, and the interest rate changes by say 1% or 0.5% or 3%, and you have to find the actual percentage change in the bond price or the absolute change in the bond price with the help of duration and convexity. So see, we'll directly jump into the numerical, but before jumping into the numerical and just throwing directly a formula which is written in a book, which is the percentage change in the bond price is equal to duration into change in interest rate plus half C del Y square. This is the formula. But why this formula? Let's discuss on this. So whenever you will have duration and convexity, you have to divide it into two steps. Step number one, forget about convexity. Just talk about duration. So assume if they say that interest rate will change by 2% and they will say interest rate will increase and you know the duration. So you'll simply multiply the duration. You'll say that the bond price will change by 10% in opposite direction because that is the definition of duration. The percentage change in the bond price due to 1% change in interest rate and duration always give you the value in opposite direction because that is a relationship between price and interest rate. If interest rate will rise, the price of the bond will fall. If interest rate will fall, the price of the bond will rise. We already know that. We know this. If yield increases, the price will fall. If yield fall, the price will increase. And that is why you will generally see a negative sign with the duration and interest rate. Okay, this negative sign is pretty important because say if the interest rate is decreasing, so what you will write -2 or -3 or -1 into negative duration, say 5, it will become positive. So the percentage change in the bond price is what? Positive. However, you don't have to mug up this negative sign into duration into change in interest rate. You should use the intuition that if interest rate will rise, the bond price will fall. If interest rate will fall, bond price will rise. We know that. And based on that, we will decide the percentage change in the bond price. So if the duration is say 5, which is I think given in the question, duration is 5, the change in interest rate is 2% and it is increasing, then the bond price will fall. So the percentage change in the bond price would be negative 10%, right? Because the interest rate is increasing, the bond price will fall. And this is because of the duration. This is what you have calculated with the help of duration. Now assume you are here I naught and the interest rate increased and went to say I2 because the increase is of 2%. You will be on this line. You will be on this line with the help of duration. We learned that. And the reason we introduced convexity, which is the step 2 in our life, because whether the interest rate will rise or fall, you will always lie on this line because of the duration. Because duration represent this line. Duration is the slope at that point. If you want to reach to this curve, this price yield curve, which is a curve, you have to add something, you have to add something. Whether the interest rate will rise or whether the interest rate will fall. We already discussed that. And we said that this something is called as half C del Y square. This is where we introduced convexity adjustment. The first session on convexity was around this half C del Y square. So half C del Y square is going to give you the percentage. But it is always going to be what? An addition. An addition. So half convexity is given as what? 40. So convexity is 40. Del y is what? 0.02 raised to the power 2. Whatever the value will come, you will always add in this minus 10%. So what you're doing duration into change in interest rate, and it will always move in opposite direction. So you're writing minus duration into change in interest rate plus half C del y square. That is the formula which is written in the book. I haven't just mentioned one thing, how you got half C del y square. That's it. And it came from Taylor's expansion. We'll discuss about the Taylor's expansion, but it is a discussion of differentiation and integration of calculus. I will, I will discuss that. And you will understand that it's not only convexity adjustment, you have to add something more to this series. So we'll talk about Taylor expansion series. And then you will understand why the formula is half C del y square, which I haven't explained till now. But leaving Taylor's series, Taylor's expansion aside, that is what the formula written in the book. It's not a formula. It's a very intuitive formula that, hey, if interest rate will rise, the bond price will fall. If interest rate will fall, bond price will rise. Therefore, negative sign. We know that the definition of duration is on an average percentage change in the bond price due to 1% change in interest rate. This is the change in interest rate. And we always have to add convexity adjustment. What is the formula of convexity adjustment? Half C del y square. Have we discussed how we got this formula? No. We just accepted that this is half C del y square. So if I calculate this value is going to come as negative 10% because the bond price will fall by 10%, because the interest rate is rising by 2% and bond duration is 5. So definitely the bond price will move in opposite direction and the bond price will be 10%. This is half C del y square. I have half, 40 is the convexity given in the question. Change in interest rate is what? 2%, 0.02 raised to the power 2. If I solve this, I'll get the value 0.8. So minus 10% is because of the duration and 0.8% is because of the convexity. The net change, if the current bond price would be say 1000, so you will do, and you will say that it will change by $98 or INR in absolute term. Okay. So I just wanted to introduce this combined formula, which is written in your book, and you don't have to mug up the formula. You can also simply use the basic intuition that we discussed here. Step 1, calculate the percentage change with the help of duration. Find the direction. It will always be opposite. It will always be in the opposite direction. Then always add convexity adjustment. That's it. With that, I'll pause. I'll see that whether I should talk about Taylor's expansion or Taylor series expansion or not, because we have talked a lot about duration and convexity. And till now, whatever we have discussed is only related to effective duration and effective convexity. We have to understand Macaulay's duration. We have to understand modified duration. So we might have to move into other important discussion than Taylor's expansion, because Taylor's expansion is not required whether you sit for FRM or CFA. With that, I'll pause here. Thank you. Have a nice day.